All right, how's everyone doing? Good? Yeah. Zoom, can you guys hear me okay? See me okay? Perfect. Sounds good. Um, kind of more of the usual with me. We're gonna do more tests today. I know that's really fun, but we're just gonna do more tests today. Try and get more on time for sure, like a minute a question. See how that goes. We're gonna be doing it out of this book, so if everyone can grab that out and flip to page 592 whenever they're ready. And once everyone's there, you guys haven't done this section, right? Or this passage. Perfect. Okay, so we're just going to start with this passage. There's 7 questions. I'll give you 7.5 minutes to start. And then after this, we're going to go back over questions from passage 1 that we had last time that I didn't have time to get to, and then kind of just keep that same cycle that we've normally been doing. Sound good? All right. So we're going to have 7.5 minutes in this passage. Try and raise your hand if you get done before the 7.5 minutes is up. time's up. Sorry if that was a little fast, but we gotta get right to about a minute a question. So yeah, we're gonna get to that today. If you didn't get all of them done, sometimes people get stuck up on a question and it takes a lot of their time. So just try and, instead of missing one at the end you might have gotten, if you're going to have to, stop yourself from taking too much time in a question, make sure you do that. Other than that, we'll go through these answers, and then we're going to go back to passage 1, and I'll talk about some of the questions you guys asked. So, starting from 14, the answers were F, A, G, B, J, A, J. I'll repeat that one more time. F, A, G, B, J, A, J. Any questions?
Last hike, could we go over one, like the first one and
So question 14.
one?
Oh, are you talking about in passage 1?
Or passage 3, sorry.
So you want to go through 14 and
18.
18? Yeah, we can do that. Any other questions in any of them? Did everyone get the last one done? Oh, sorry, what were you saying?
19 and 20.
Yeah, I can do 19 and 20. Okay, is there any questions on 15, 16, or 17? Okay. All right, let's go to passage 1. Hey, by the way, how far did you get in that? Okay, perfect. I'll go through those 3, so you'll be caught up. Perfect. Okay, if we go back to passage 1, I know it's been a while since you've seen these questions, so I'll try and be extra explanatory so I can remind you guys. We had questions on number 1, number 3, and number 4. So I'm just going to go over those real quick. So just to give you guys a broad overview again, maybe spark your memory. This passage talks about a species of snail and the algae it eats, and like the different kind of exposure to direct sunlight, how it affects how much of that type of algae it eats, and all that kind of stuff. So question 1, it's pretty much, this is just a graph reading question, just understanding, where to look. Oh, sorry, passage 1, so 588. Yeah. So question 1, just you're reading this like histogram you see, and it's asking of the combinations, which one like was consumed the most by the snail. So when you look at this, what I noticed is there's only green and yellow brown that in the answer choices. So that means that you're only looking at the light gray and the like striped one. So a lot of people get stuck up because when you look at it, you notice that at 6 and 9 hours, right, neither of them are like the most. At 6, the yellow brown is the highest out of the group of 6, but that's still not higher than looks like golden brown and red in the 9-hour group. So people get stuck up on like, oh well, there's no answer choice that's the actual highest. This just specifically asks for out of the group. So then you just have to go and see, looking at both of the gray ones from 6 and 9 hours, because you notice that that's the 2 other variables in the answer choices, which one's the highest, and you can see that it's the light gray, which is the green, at 9 hours. So that has to be your answer. I know that was a long and stretched out like a response, but I hope it made sense. Question 3, you have to read the passage, and you have to have a little bit of outside understanding or information. You have to understand the difference between an autotroph and a heterotroph. If you don't know what that is, an autotroph makes its own food, like a plant, and a heterotroph uses other organisms as its food. So you can see that the snail, L. littorea, or however you say that, eats algae, which is another organism, so it's not a heterotroph, or it is a heterotroph, not an autotroph. So that eliminates C and D. and then you have to just match it up. So A, what's
Because it requires prior knowledge, does that mean this passage would likely be not graded?
no, there's I mean, sometimes it's just you do have to know you have to have some basic outside knowledge of biology, chemistry, just like a basic understanding of some things. Sometimes it's going to be difficult if you don't know it, but on most tests, I'd say there's probably 5-ish questions that require some outside knowledge and understanding. I don't think there's any likeliness that I can give you on whether that would mean that these are ungraded or not. I'm not quite sure on that. This is very brand new, but I can look it up and maybe try and find that for you later. Anyways, yeah, so you need a little bit of outside knowledge, understand the difference between those two. Additionally, I believe you have to have a little bit of outside knowledge on this one, which is difficult. You have to understand kind of what hemoglobin is and chlorophyll is. Chlorophyll is chlorophyll helps plants undergo photosynthesis, which is how they make their energy. And hemoglobin is the stuff that's in your blood that helps get oxygen throughout your body. So this is asking the primary food source, which is the algae. Does it contain chlorophyll or hemoglobin? You have to understand that chlorophyll is in plants and hemoglobin is in humans, or not humans, animals. So therefore it has to be chlorophyll, and then you have to match up the end of the description again. And it's talking about photosynthesis, which is something that plants do, and then it matches with algae. So it's kind of difficult, again, if you don't understand the outside information. But yeah. Is there any questions on those? Those make sense? Yeah? Okay. Perfect. Looks like your next passage is passage number 4, which is on page 594. This has another 7 questions. I am going to push it down to the minute per question. Try your best to get all of them done. I know it's quick, but that's how the actual ACT is going to be. So if it's too fast for you and you don't have enough time, make sure if you're stuck on a question, you don't take too much time on it. All right. Time starts now. Good luck. Time's up. That was probably fast, but gotta simulate how it's gonna feel on the real one. Okay, so for this passage, starting from question number 21, your answers are B, J, B, G, C, F, D. I'll say that one more time. B, J, B, G, C, F, D. Are there any questions on these?
26.
26, okay. Any others? Any questions on Zoom?
Could we go over 21?
Yeah.
And 25?
Yeah, no problem. We'll go over those two, as well as 26. If there's no other questions, then we'll go over our questions from passage 3. We had questions on 14, 18, 19, and 20. So I'll start from 14. So for 14, though it says, like, based on the results of experiment 2, which, you know, makes you want to look directly at experiment 2, you do have to have a basic understanding of the whole thing. So this is where skimming through the original, like, passage would be a good tool to use before you start. It's saying, based on the results of experiment 2, as the spring constant of the spring on which what?
Where are we right now?
Passage 3, page 592. Okay. We're on question 14. We're going over it. Okay, so this says, based on the results of experiment 2, as the spring constant of the spring on which mass 2 was placed decreases, the force on mass 2 what? So we have to understand the different spring constants that were used in this. We can see that in experiment 1 and in our passage. Our passage says steel alloy X and alloy Y has spring constants of 2.5, 3, and 3.5 Newton meters, I think is what that is, respectively. So that tells you, steel is the least, alloy X is in the middle, and alloy Y is the highest. So you can see, and then it says go to experiment 2 and talks about mass 2. So if you go down to table 1, that's where we're looking. Mass 2 is the middle row, and you can see that steel has the least spring force, alloy X has the middle, and alloy Y has the most. Does that remind you of any pattern? It should. It's the same pattern as our spring constant. So therefore, it is a positive, or like if you just want to think about it, like as one increases, the other one's going to increase. So if then it says, if the spring constant on the spring on which mass 2 is placed decreases, if they both do the same thing at the same time, therefore the spring force has to decrease as well. So it has to be F. Does that make sense for everyone? Okay. So our next question was on 18. 18 says, suppose that in experiment 1, the scientists had attached the mass onto the end of a spring with the spring constant of 2 Newton meters. The distance of the stretch would most likely have been, and then it gives different answers of numbers. So we remember our different spring constants. It was 2.5, 3, and 3.5. So we're looking at experiment 1 and at figure 1. You can see that steel stretched the most and alloy Y stretched the least. That is an opposite relationship to those spring constants that we spoke about earlier, since steel is the largest. So the way that I like to think about it is I looked here And then notice that steel is the most, and that steel is the closest to our answer, right? So going towards our answer, we'd go like from, like if you want to think about it as directions, we'd go from alloy Y to alloy X to steel and then to our answer, right? If we're going to put it on a graph. And we notice that as we go from right to left, it's increasing. So if we're going to keep on going that way, it's going to keep on increasing. So if we look at our answer choices, we have less than 0.14. That doesn't make much sense, right? Since that would mean that it would go to 0.2 and then back to shorter than alloy Y. That doesn't make much sense. That doesn't match our pattern, so it can't be that. Both of these other ones are the same thing, except for they're just talking about like in between the two. So like, is the spring constant in between alloy X and alloy Y spring constant? No, so it couldn't be between 0.14 and 0.17. Is it in between X and steel? No, it can't be H. So it has to be greater than 0.2, which matches the, like, with these ones you just have to think about, like, patterns, I guess. Pattern recognition is a big one on these. So if you can recognize the different patterns that go along with all the different variables, that's what you kind of need to do on these. So the answer is J, because that just matches the pattern of the spring constants compared to the stretch that they got when a mass was added on the end. Does that make sense? Okay. Question 19. Suppose that in experiment 2, the scientists had tested a mass having the same length as mass 1, but a smaller displacement than mass 1. Which of the following statements about the spring force on this mass would be correct? So then you look down at the bottom. This says that it has the same length of mass 1, so 5 centimeters would be the length if we look at table 1. And a smaller displacement, so the displacement would be just less than 0.15. So what I did was, you can see the only difference between mass 1 and 2 is that 2 is longer in length, right? And then you can notice the only difference between 2 and 3 is that 2 has a higher displacement. So again, we have to recognize more patterns, see what changes when the length changes, and then what changes when the displacement changes. So if you look at 1 and 2, I'm sure all of you guys noticed that the spring force is the exact same, right? The for steel, alloy X and alloy Y, they're all equal. So when the length changed, there was no change in the spring force. Then if we look at 2 and 3, when the displacement increased, we notice that all of our spring forces increased as well, right? So now we know when displacement increases, spring forces increase. So they have a positive relationship, or they do the same thing as each other, whatever you want to think about it as. So in the question, it says if it had the same length, we know length doesn't really matter, right? But a smaller displacement, we understand that displacement goes the same way as the spring force. So if it was a smaller displacement, the spring force would be smaller. So we have to look at all these answer choices. A was the correct one, but let's go through why the other ones are wrong. So B is wrong because B and C are both wrong, because they say, like, as the displacement goes smaller, the spring force would have been greater. We know that's wrong because that doesn't fit our pattern. D would be incorrect because it's saying that steel's spring force would have been greater than alloy X. There's absolutely nothing in the table on any of the different masses that were measured that say that steel is higher in spring force than alloy X. Alloy X is consistently higher, so that doesn't make much sense for it to be that. If we look at A, it says that steel would have been less than 0.38 newtons, and we notice that that makes sense because that was steel's spring force for mass 1, and the displacement's going smaller than mass 1. So therefore, it has to be A. Does that make sense? I know that was long-winded, but I hope it helped whoever asked that question. Okay, and then 20, this says, assume that an exercise machine contains two spring hangers to hold counterweights. The first spring on the machine has a spring constant of 15.2 Newton meters, and the second spring on the machine has a spring constant of 13.1 Newton meters. Based on the results of experiment 1, which spring hanger would most likely have the greater distance stretch when a 25 kilogram mass is hung from it? This is more pattern recognition. I know this is all pretty much, it's just pretty much testing your understanding. So we have to understand from earlier whether the spring constants have a positive relationship with the distance stretched or a negative relationship with the distance stretched. So we can remember from, I believe, yeah, question 18, we figured this out. We figured out they have a negative relationship or an opposite relationship, which means that like as one increases, the other one decreases. So this is saying which one would have the greater distance stretched. So to know, like we're using the opposite relationship, if the distance stretched is going to be greater, then the spring constant is going to be less. Does that make sense? Since they're opposite. So then we have to understand which spring has a less spring constant, and that is spring number 2. So that eliminates F and G immediately. Then we look and we have to see, we have to just match the end part. H says the distance stretch increases as spring constant increases. We know that's wrong. They're opposite. One's going to increase while the other decreases. So it has to be J, which says that the distance stretched increases as the spring constant decreases, which is the relationship we had found. Does that make sense? Okay. Sounds good. All right. I know that was a lot of talking, but had to explain those. Okay, our next one is passage 2. It's on page 590. You have another 7 questions. I'm going to give you that 7 minutes again. Try and get as much done as you can. And if you don't get to a question, make sure you ask, and then I'll just explain what you would have seen doing that question. So your time starts now. 7 minutes. That's your time. Just so I know, did any of you guys not have time to complete those questions? Okay. Anyone on Zoom not have enough time? It's okay if you didn't. Sometimes, like, you can just take a longer time on the specific question set. Okay, so that's good. Everyone had time. All right. Okay, then we'll just get into the answers on passage 2, and then I'll respond to the questions from passage 4. So the answers for passage 2, starting from question 7, are A, H, C, J, A, G, A. So, I'll go over those one more time. A, H, C, J, A, G, C. Do we have any questions on these?
13.
Sure can.
Can you repeat them? Because you said C one time and A one time.
For which one?
For the last question. What's
Sorry,
the answer to the last
did I? It's A. Sorry, I might have accidentally said C. Yeah, 13's A. Okay. Any questions other than 13? All right. Okay, let's go back to passage 4, which is on page 594. We had questions on 3 of them. Those ones were 21, 25, and 26. So we'll go through these. Just so you guys know, if I'm ever explaining a question and something doesn't make sense that I say, just stop me and I'll re-explain. I know sometimes I'm not the best speaker in the world, so I'll try my best, but just stop me if something doesn't make sense. Okay. For 21, it doesn't specifically tell you, but we're going to table 1. It asks if a batch had been mixed, so like a batch of the water and ethylene glycol was mixed with 55% water and 45% ethylene glycol. The FP, or the freezing point, would have most likely been. So when it says most likely, we understand it's an estimating question, right? So we're going to go to table 1, or you can go to figure 1, whatever makes more sense to you. I'm going to use table 1 for my example, and see where it was closest to 55% water and 45% ethylene glycol. If you notice, or if you look, you can notice that between batch 3 and batch 4 is the exact midpoint of where that 55-45 would have been. So I'm going to use both of those values for my answer. So between 3 and 4, the freezing point would have been between negative 14.8 and negative 36.4. So that just immediately brings me to my answer B. The reason why I knew to look there is because those are just the 2 closest, right? And if you have 2 values that are here and here, and they're like they have a straight line between them, you can easily estimate the one in the middle just by using those 2 values. So yeah, that's how I got my answer B. Does that make sense? Whoever asked that question? Okay. 25 is very similar. This is asking for the freezing point depression, which is the triangle FP, or if some of you guys know what the triangle is, that's delta FP. So it says, suppose a batch has been prepared with 65% water by volume and 35% ethylene glycol by volume. Based on figure 1, so it tells you to look at figure 1, the delta FP for this batch would have been closest to what? So I'm going to go over to figure 1 and literally just go and find, so this bottom from left to right is the ethylene glycol by volume. So I'm going to look, this one specifically says 35%, so I'm just going to go to that 35% mark, which is right between the 30 and 40, and see where that is close to. That's pretty close to negative 40. and that's one of my answer choices, so it has to be C. Does that make sense? Okay. Then 26. This says, which of the following statements explains why delta FP was 0 degrees Fahrenheit for batch 1? The volume added was 0 milliliters for one of the components of the. And then it has a colon. That colon means it wants you to continue that sentence. So it's like beginning the sentence for your answer there. So like the volume added was 0 milliliters for what, and then you have to continue that sentence. So one of the components of the, we see that there's two different kinds, right? And this is going to eliminate two of our options. It's either mixture in the flask, which is in F and G, or cold bath, which is in H and J. If we read the passage, we understand that the cold bath is made out of, I believe it's acetone and dry ice. Yeah, acetone and dry ice. But that isn't something that ever changes throughout the question. So originally, we understand like that's not going to be something that we're going to be tested over, right? The cold bath isn't going to change, and there's not going to be 0 milliliters added of anything to that cold bath. So we're going to immediately knock off H and J. And then the way I like to do these ones where it's like several components, I like to just find the differences. So again, the differences between our now only two possible answer choices are, in F, it says ethylene glycol was the thing where 0 milliliters was added. And in G, it says water had 0 milliliters added. So this is asking about batch 1, if we go back to the question. So let's go see. If we go to table 1, we can see batch number 1 had 100% water and 0% ethylene glycol. So, therefore, if there's 0% ethylene glycol and 100% water, obviously, if it was 100% water, there can't be 0 milliliters added of water. So, it has to be ethylene glycol that had 0 milliliters added. So, that just leaves you with answer F. Does that make sense? Okay, perfect. We have a couple of minutes before break. I'm just going to try and explain the question from passage 2. So if you give me 30 seconds, I'll be able to explain it. Okay. Yeah, this makes sense. Okay, so this question gives you a table that explains how you know if like the infectivity of the virions, however you say that, is active, attenuated, or inactivated, and it gives you different numbers for the relative infectivity. So it immediately tells you to look to experiment 1 to see the total number of petri dishes that had inactivated virus samples. So we go to experiment 1. I'm sure you guys read the passage. I didn't have enough time trying to explain real quick. But we immediately can understand. So, and then it asks in experiment 1 how many contained inactivated virus samples. So if we go to the table that was given to us in the question, we can see inactivated means the relative infectivity was less than 0.2. So we just go to table 1 and we look for how many petri dishes of the 8 that are there had a relative infectivity of less than 0.2. And we can see that at the pH of 3.5 in 1 hour and 1 day, they were both 0, which is less than 0.2, and there's no other ones that are less than 0.2. So it has to be 2 as our answer. It's 2 separate petri dishes. Does that make sense? I think you asked that question. Does that make sense?
Yeah, I just thought it's like greater than 2. I just misread it.
Oh, it's all good. Makes sense. All right. Time for break. I think you guys probably have 5 to 7 minutes somewhere around there. Good job. I'm not sure if I'll even see you guys again, so thank you guys. If I do, then that's kind of awkward, but thank you guys. Have a good rest of your day.